Hi there, and welcome to Weekends Web App. This is day one, and we're going to be getting started with the actual development of our web app today. If you didn't catch them before, we had a couple of pre-streams, day 0A through to day 0C, where we set everything up so that we could actually write our code without having to deal with tooling at some sort of slow rate. If you want to catch those, they can be found at the Weekends Web App repository. Which is github.com/weareoffsider/weekendswebapp. So that's where you can get the code, and you can go to YouTube to get any of the old streams if you want to catch up and follow along. Once you've cloned the repo down, you can find it with find this particular day. You can start at this particular day by going git checkout day 0C. We're not going to do that right now. We're going to get back on master. Anyway, so for those who've just started joining in, we're going to be building a complete web app from scratch on stream. Absolutely no code is going to be put down while it's not on camera. So my intent with this series is to make essentially a start to finish experience where you can see pretty much everything that goes into building a web app, all the HTML, all the CSS, all the JavaScript, and eventually all the back-end code. So with that, we may as well just get started. I'm not going to give away precisely what we're building to start off with. There are a lot of things that you need to build for a web app just to get started. And it doesn't really matter what web app you're going to build. You do need to work for those things first before you can really build anything of actual note. What we're also going to be doing is avoiding frameworks as much as possible. A lot of this time I want to be spending building things at a low level, working with DOM APIs directly rather than relying on lots of libraries to do the job. Yes, we might get there faster by relying on all those libraries, but we won't necessarily understand what they're doing. In addition to that, we're going to be writing this web app my way, and there's a lot of people with there's lots of different ways to build a web app. So I'm only going to show you one particular way to write a web app, and to be perfectly honest, the way I work, I often do just write the code I need rather than depend on libraries. And the reason for this, and this is why it's a good learning aid as well, is because when you know how to write what you want, you can get exactly what you want. You don't have to make any trade-offs where it's like, well, we've got this library here, but it doesn't quite do what we need. If you understand how it works, you can make the modifications necessary. If you don't, you're kind of stuck, and you can get an 80% solution, but you can't go any further. Anyway, I'll quickly bring up the README and just talk about the tools that you'll need if you would like to follow along at home. You will need, missed one here, you need Git on your machine because you'll need to be able to use version control to pull down the code. I'll just show briefly how to do that. So if we have a look at the repository here, it's on GitHub, and the location for that is github.com/weareoffsider/weekendsapp. You'll find down at the bottom right here a URL, clone or download. So you can take that URL, and let's say if we were going to go anywhere at all in the terminal here, if you've got Git on the command line, you should be able to clone it down somewhere you want. So have to give that a name. So if you run git clone, you should be able to get a directory that's going to look exactly like the one that I'm working from here. And then from there, you can have a look at all the different days. You can get any particular day by checking it out. And these days are always by the last day. So if you want to work on day 1, you want to pick up day 0C. If you want to work on day 2, you'd pick up day 1, and so on. Anyway, we don't need that anymore, so I'm going to get rid of that. Get back into our main project directory. We're also going to need a text editor. I personally use Vim, but you don't have to. It's a point of preference. Everyone has their own thing that they use. I certainly don't actually recommend using Vim unless you're willing to spend some time getting really good with it, because otherwise you're just going to take a really long time and you're going to get frustrated. So choose the text editor that works best for you. There's a lot of choices out there, stuff like Atom, Sublime Text, VS Code is a good one. Emacs if you want to live on the other side of the fence from Vim, or you can get Vim, but don't say I didn't warn you. You also need access to a terminal, and this will be easy to find for Linux users and Mac users. With the terminal, that'll give you the ability to run all of our tooling, run our commands, and generally lots of work will be done from the command line. If you're on Windows, there is ways to get a Linux-like command line, but I'm not really going to go into that. It's better to either go look it up on the internet, or eventually maybe I'll be able to put in the comments here some sort of guide for that one. But I'm not going to go into it right now because I'm not on a Windows system. You will also need a web browser, something good for use for development. So there's Google Chrome, which has great developer tools, and you also have Firefox Developer Edition, although it's not really that much different from Firefox itself. So both of them have great developer tools. I'll be switching between the two. You'll see at the moment we have Firefox Developer Edition running, but I'll be using them interchangeably. It's kind of good not to just work on one browser, because eventually your web app is supposed to work everywhere. In addition to that, we have a few tools for using Node on our command line. Node is a JavaScript runtime that's used on your computer, not actually in a web browser. And the whole purpose of that runtime is to give you access to a lot of tooling. You can technically run servers with it. I mean, you can run servers. I wouldn't say technically. You can run servers with it, but we're not going to be doing that. We'll only be really using it for our front-end tooling. So all of the things that will make our development experience nicer will pretty much be written in Node. We'll use MVM to install it. We'll use Node. That's what installs Node. And then we have a package manager called NPM, or we're mostly actually going to be using Yarn to do our work there. Again, most of this is covered in the tooling streams. So if you want to go to day 0 and check those out, you're more than welcome. But as it stands, we'll be getting stuck into the actual HTML, CSS, and JavaScript in just a moment. So that leaves us with a blank canvas for us to get all our work done. We've already got a build tool set up. So when I type in gulp, that sets up a development server, and it also starts building our HTML, our CSS, and our JavaScript. We don't actually write those languages. We write something a little bit different. So we write Pug and Jade for our HTML. We use TypeScript for our JavaScript, and we use Less for our CSS. And most tooling languages, even though HTML, JavaScript, and CSS is the language that comes out at the end, most people don't write directly into the browser anymore, because the scale of the applications we're writing is just way too big for us to really depend on that and have that be a viable solution. So what we do instead is we write some higher level language that's maybe got some nicer features added to it, some future features of JavaScript, because JavaScript as a language is always evolving. And we write in those languages, and then they go through a compile step that turns them into the code that we want to write. Again, all of that was set up ahead of time, so if you want more explanation about how that all works, you can go back to those streams. But otherwise, we're essentially going to focus on moving forward and actually getting words on the page. And we will go over all of this stuff as we go. So even if you're a raw beginner, we will be covering over many times how JavaScript works, how Less works, how Jade works in the context of doing works, because we don't want to get too bogged down. There are plenty of beginner's guides out there with all the minutiae and whatnot. What we want to do is we want to keep on moving forward with the app as a whole. So with that said, let's have a look at our starting point. So we have our HTML written in this Pug, and I'll just sort of demonstrate what this actually becomes, because that'll help. So our Pug is our HTML, and unfortunately it's made to not be pretty at the moment. I could turn the prettier, it's not changing for me. That's all right. We'll look at it over here. So we have our HTML, and the Pug over here turns into the HTML over here. So hopefully you can see that structurally it's pretty similar, and it just means that we don't have to type quite so much to get our HTML. And this forms our shell at the moment. So the title, the HTML, sorry, let me start from the start. The doc type up the top tells the web browser that this is a modern HTML5 HTML document and to pass it as such. And then after that, we go through the structure of the HTML. So we start off with the HTML element. Inside that is the head element, and the head element is meant to carry essentially lots of metadata about this document and also assets that it might have to get, such as style sheets, which we'll talk about in a moment. And you can also see the title tag here. Now this title tag is what shows up in the tab of your browser. Carrying on down to the body element. The body element is what goes into the middle of the page, and since I've made it completely empty, it probably bears explaining. If I was to put in a H1 tag, which is a short for heading 1, if I was to put in a H1 tag and make it say Weekends Web App, that would put that into our web browser. You can see that there. So that's a H1 tag. And there's plenty of other tags that all represent different things. And essentially, HTML is about structuring documents, but we've taken a lot further when it comes to making web apps now. So all the building blocks for a web app are now being repurposed. Well, not repurposed, but they are certainly being augmented to a point where they're not just documents now, but indeed full-blown applications. And we'll be going through all those different elements as we go. These script tags here are things that reference JavaScript. And this one here, this assets app.js, that's the one that references our JavaScript that we're going to be running soon. But we're going to get into that real soon. Going back up to the head, so that covers over the HTML. We've also got a link to this style sheet. And the style sheet is essentially something that is a CSS file that stands for Cascading Style Sheets. And that tells the web page what to look like. So if we were to go to app.less, it's got nothing in it at the moment, but say I wanted to tell the body to have a background color, a particular background color, I could do that. I could go body and then this brace. So the body selects an element on your page and then you give it a series of instructions, and that could be background blue or color, which is short for text color. We could get red text color there. So if you take a look over here, you'll now see that we have a blue background and we have a red color for our text. And this goes further as well. So we can do things such as take that H1 element. We can style specifically that. So we could give it a font size that is really tiny, for example, or really big. And we can also change what type of font it is with font family sans serif, as you can see here. Now what I'm writing here is pretty much CSS. I mean, it is CSS, but Less also gives us some extra features which CSS doesn't necessarily have. So for example, we can create variables such as this color blue variable. This is obviously going to be a facile example, but this gives us the ability to reuse things in various places. Say for instance, if we wanted to also have a background on this isn't a great example, but say we wanted to also reuse that color blue as a background on the H1, we could do that by doing that here. And that way we can change both of those things at this point, rather than having to go through the code and check all the different places where it is. That said though, we are not going to be doing an awful lot with the the CSS to start off with, just while we're setting things up. But in the interest of not getting too bogged down in JavaScript, we'll probably get back, try and jump around rather than just spend all of our time in JavaScript, although we certainly will be writing a considerable amount of JavaScript. And that brings us back to JavaScript, I guess. So the JavaScript is referenced at the bottom here with the app.js, and that JavaScript will essentially get run the moment it's loaded. And you can see here, all we have is a command called console.log. So this is a function call. So it found the console object, which has a bunch of different things like error. It also has warn and a bunch of other things, but the main thing that we'll be using a lot of the time is a console log, just to see what kind of results we have in the application. And anything that runs into our console log, if we go over to our developer tools and we click on console, we'll see that hello world just there. So So that can tell us that the JavaScript is actually running. If we were to change that, oopsie daisy. Well, we've got to refresh manually. There we go. And then you can see there, hello world 2. So it's changed. Anyway, that's enough of the slow lane. We're going to start getting into what it is that we're actually going to do in this web app. Just give me one moment to grab a drink and we'll go through it all. Alrighty. So when we build a web app, there are a lot of things that need to come together before we can really build anything. When you think of a web app, there are a whole bunch of different concerns that need to come together. And we're just going to start listing them all out because nothing like a job list for this one. So we need to build the Weekends web app. And what we're going to talk about is essentially what forms our platform layer. And platform layer is sort of a term I stole from a stream that's essentially the inspiration for this, Handmade Hero, where he talks about building a game and making sure it runs on every platform. Well, with a web app, we sort of got to, that's almost a given. We have to make sure it runs on every platform because a web app is by nature available to many, many web browsers. So what are our targets? We've got to make sure we've got to hit Firefox, we've got to hit Chrome, we've got to hit Internet Explorer, we've got a niche Samsung browser, which is sort of a subset of Android. We've got all the Safari browsers, and I'm probably going to miss some because I'm just doing it off the top of my head, but the whole point is there are a lot of platforms, and while they all have agreed on a standard, and they're all meant to hit that standard, it's not enough for us to just target that standard and assume everything will work. So it's important for us to understand when we're writing our code that we need something sort of in between our very nice and well-constructed code and the real world where things actually need to work. And for however long, jQuery was that layer. And that was before we started writing things, before we started writing complex applications like this, and also before web APIs had gotten their collective heads together and actually done a good job of standardizing. These days, jQuery is still useful if you absolutely do want your code to work, but it's a lot easier to hit the minimum level of compatibility that you sort of want to make sure you're hitting the whole browser market. And it also depends on what clients you're serving, because there's certainly some poor people in government and whatnot who still need to serve browsers like IE7, IE8, IDE9, and even worse if they're supporting IE6 or something like that, which are thoroughly antiquated browsers at this point. But because of all of that, we need to make sure that we have a layer in between us and our code that we want to write and the real world. And we want to make sure that's all fairly nice and bulletproof and we can depend on it, but it's also not too hard coupled between it. So we're not writing code that we can't deal with any changes to that platform layer. Because if we can't deal with any changes, it's going to make our application very hard to work with in about 100 days down the track or whatever. So there are a bunch of things that I know from having built these things that a web app needs. And often the first answer to that is going to be routing. So what I mean by routing is whenever you go to a particular location, let's say it's a page about stuff, you want something to happen specifically there. Or if it goes to the wrong page, then you need to tell the user that they're at the wrong page. And usually the server would handle this, but because this is going to be an offline-based web app, and that's actually the one other thing that we should probably get out of the way right before we get too far into things. This app, to start off with, will be web technology only. So we're not actually going to depend on a server for anything else other than the HTML, the JavaScript, and the CSS. Down the track, we'll eventually need to talk to a server, but because this app, to start off with, will only be the user's own data, so they'll be able to use it to edit some sort of files. I won't give the whole game away, but essentially it will be used to manage something that the user keeps to themselves and maybe exports and imports, and that's it. And because of that, we can pretty much dodge the whole what about a server issue for a long time and focus just on web technologies. But because of that, we definitely need routing. So we need the web app to know where you are, so that if you end up in a certain place and you hit refresh, or you as you click it, you can see the URL bar keeping moving forward, because otherwise you can't do bookmarks. There's a whole lot of things you can't do. So we will need to do routing. And what else do we need? We will need translation. Or, to be more accurate, let's put a bigger umbrella over that, and we'll call it internationalization and localization, which is shorthand for these is L10N and I18N, just because they're really long words. So, internationalization and localization involve the two steps of making an app able to be translated, able to be made local. So internationalization is the process of making your code fit for that purpose. And then localization is the actual process of going, all right, we have this application that is okay for English, but we now need to make it good for this language and this language and this language. So internationalization is where you make sure your code is able to handle that. And that usually means that you need good translation functions. You need a good way to handle dates and times, of varying formats, of varying localities, and time zones is one of those things that can really mess with people's heads. Numeric formats. Some people don't use decimal points and commas in the same way, so there's a need for localization in numeric formats. And that goes even further, although we won't necessarily deal with it as much. There's a point where you'll have right to left layouts. You'll also have what's the best way to say this? You'll have right to left layouts, but you'll also have languages that are far more verbose than others. If you've ever seen a German/Swiss site, the language there is extremely verbose compared to the English language. So you'll find that all of your perfectly aligned little buttons are suddenly kind of a bit too tight together once you get into a much more verbose language. So there's also design considerations involved. But once you get into those layout considerations, this internationalization, localization thing becomes a little more context sensitive. So we're not getting too deep into that to start off with. But we need to handle that case. Next off, we will need some sort of memory storage or application state. And there are a number of ways to store application state. So when we talk about application state, there's in memory. And what I mean by in memory is it's simply in an object or some sort of structure in your JavaScript code. And you can immediately get your hands on that in-memory information. But the one thing about in-memory storage is it's lost every time there is a refresh. So to be really specific about that, if we were to go here and say I was to make a variable called A, which you see down at the bottom, and we'll call that this is data true. Yep. So we have this object A, this is data. And this is, for all intents and purposes, say our in-memory storage for the app. The moment we refresh, it is gone. And we no longer have access to it. So you can see A is not defined there. So we need some way for in-memory storage, but we also need something more than that. And that something more is going to form a local database. And the technology for that is IndexedDB. So here we go, a low-level API for client-side storage of significant amounts of structured data, including files and blobs. And the API allows for indexes to enable high-performance searches of this data. Realistically, it's Mongo, or essentially a NoSQL store on your browser. That's oversimplifying, I do know, but it's a fairly powerful API that allows you to store a lot of data, store it in a structured manner, and do relational stuff, although potentially not as good as a proper SQL database. It's essentially what you have as your standardized solution. There are browsers that implemented Web SQL, but that is not something anymore. Not a thing anymore. It was for a little while. They don't even have the web storage API there. Yeah, they don't even have it in MDN anymore because that's how old a thing is it. There we go. So the API is currently unfrozen. Yeah. So WebSQL as a concept it sort of went nowhere. They wanted to do it, but like a bunch of people tried it out, but they wanted an independent implementation, and IndexedDB ended up being that thing rather than just sticking WebSQL a SQL browser into the a SQL database into the web browser. So IndexedDB is essentially our choice, our current choice for now and forever for a large amount of structured data. So that's your local database. The one big downside, well, it's not a massive downside, it is what it is, but local database is not synchronous, which means we can't get the results of any query immediately. So we do need to wait for it. So there is an alternative for things that we do want immediately, and that is local storage. And that's the storage object. And essentially, so all of these storage items are they're restricted to your domain, so that's how they remain secure, so to speak. And that all of these storage objects are synchronous, so you get them immediately. And I know I just introduced a new term there. So the concept of asynchronous versus synchronous. Asynchronous means that the thing happens and it doesn't give you a result straight away. Rather, you can continue to do something, and then likely what they will give you is some sort of what's called a promise or a callback or something like that, where it will then tell you, hey, I'm ready and I've got the information for you. Asynchronous code, you have to essentially do a lot of thinking about things that happen over time, and it can be a bit confusing for beginners, but it is the reality that we live in when we work with JavaScript. So we are going to be doing a bunch of asynchronous code. That said, though, sometimes we do want the answer straight away. And that's why local storage can be useful. So that will be for local storage and session storage. The difference between the two being that your local storage will hang around after you've refreshed the browser, whereas your session storage, I don't lean on session storage too much because honestly I just mostly use in-memory storage. So the data stored in session storage gets cleared when the page session ends. A page session is as long as the browser is open and survives over page reloads and restores. Okay, yeah. So session storage will essentially go away not when the tab closes, but when the whole browser closes. So it won't survive restarts, whereas local storage will survive if you restart your computer and come back. So local storage is usually, I'll only use it sparingly. Typically for certain things that I want to have straight away, like knowing whether the user's logged in and I should start going straight into some sort of login state when the application is loading, rather than having to ping it and waiting potentially extra time. So it allows you to make some assumptions with local storage there. So with in-memory, local database, and local storage, we'll have enough for our application state. Now, down the track, we'll also need to be able to talk to some sort of external service, our back-end server, or anywhere that we need to get information from. So while we won't be doing that straight away, we may as well list it in our to-do list. So we'll have essentially a API communication layer. And there are two technologies for that. They're not too much different, but essentially, if we look at XML HTTP request, so the fairly old school these days way of doing it is using XML HTTP request. Honestly, I quite like it as an API. It's pretty straightforward. I mean, yes, I still check the docs while I'm building one for the first time, but it's fairly straightforward if you can write your own layer around it to get rid of the tedium. That way, you have full control over how your request gets made. The other API is fetch. So the whole idea of this new API is to give you a bit more flexibility with how you work, and it's a bit easier to put things together. But there is no support on IE, according to this guy, which means it's kind of unfortunate. But you do still have to keep in mind other browsers, which is honestly why I've stuck with XML HTTP request for the most part. But anyway, we need an API communication layer, and that will come in. And what that will need to handle is it'll need to things like GET requests, POST requests. It'll need to handle file uploads, because this app idea we have, it's going to involve some degree of file uploads to the backend server, and possibly even WebSockets. We may use a library for that one, but WebSockets is a means for us to create a socketed connection. Let me think of a real good way to simplify it. It allows you to create that connection with a server. So rather than constantly, say, checking in every 10 seconds or something like that, or performing what's called a long poll, you literally just open a connection up, and that connection persists, and it's bidirectional. So you can send messages to the server can send messages to you. And all of our modern web apps that use chat and that kind of thing, pretty much all of them will be built on WebSockets, because it's just the fastest way to establish such a connection and provide you the data in real time. So you get that sort of that real time feel that you're really looking for in a modern web app these days. So that'll form part of our API communication layer. Now, what else do we need? So we will probably at some point need notifications. We might need a location service. We might want sound. Probably not a lot of sound, but most web apps have at least a little bit of sound, some sort of notification sounds and that kind of thing. What else? So when we talk about routing, we're probably looking at other things, like we're looking at how we loading transitions between those routes. So if we were to go back to the land of routing again, we could talk about loading transitions. We'll probably talk about, in terms of our platform layer, there will be a lot of utilities that we build out. So utilities for let me think of the best way to say this. We'll have utilities for doing common DOM operations that maybe have some compatibility concerns that we need to make sure of. So rather than doing them by hand every single time through the app, we want to just have some common DOM operations. DOM stands for Document Object Model, and usually when people are talking about DOM operations, they're talking about interacting with all of these different elements, because you can create new nodes, you can delete nodes, you can transform them, all those operations. Most of the APIs are pretty good for them these days, but there are some things that you sometimes need to have some degree of compatibility layer to make sure you're getting it right every single time, and making sure you're supporting all of those browsers you're meant to support. We'll probably have math operations. We might need vector math. We might need, there's a bunch of things we could use. And probably have function helpers in there as well. That's really vague, so I might leave that one for now. Right. So we've also got, so when we talk about application state, we'll also need to distribute application state to the view. And maybe this doesn't really form part of the platform layer. At the point of time we're talking about views, we start talking about the actual app itself. So I think I'll leave it at that point. I am sure other things will come up at some point. but this stands as a good sort of platform layer to begin with. And once we start getting on from there, we'll start making decisions about how our actual app is structured and see if there's any more items on this list that we should handle. But for the moment, we're 35 minutes in and I haven't laid down any code. So I would really like to start doing that. So what we're going to start off with is we're going to knock off the top of the list and talk about routing. But to do that, first of all, we need to have some sort of code that essentially knows when everything else is ready so that it's not going to accidentally start running before other parts of the document are loaded. And this is document ready. Now, I've sort of offhandedly talked about it, but I will very specifically talk about it. We will be using MDN, otherwise known as Mozilla Developer Network, a lot, because the web docs from the Mozilla Developer Network are far and away the best. They're well contributed to, and they're up to date and just extremely primo quality. So make sure whenever you're doing any web development that you've got that you know where you can get the answers from, because the simple fact is I do not have all the answers in my head, but it's important to know where to get them, because then you can get started. You can actually use that as a reference every time you need to do things. And the event we're going to be calling, so now getting into what we're actually going to be coding, we need to listen out for when all of the DOM content is loaded. So you can see here, the DOM content loaded event is fired when the initial HTML document has been completely loaded and passed, without waiting for style sheets, images, and subframes to finish loading. The key thing about it is the DOM content loaded means that everything here has loaded, because the important thing to know is that all of this comes in a stream. So you don't actually have all the DOM elements straight away. I mean, most of the time it looks that way because this loads so fast, but there is actually a process where you don't have the whole document all the time. So DOM content loaded gives you that final event. And here's a nice little example for us. So you can see here, document add event listener. So the document element, and we're going to attach an event listener to it called DOM content loaded. So we'll do just that. As said before, I'm writing TypeScript, which means that's going to, you'll see my autocomplete gives me a lot of really good information and means that I probably won't make as many mistakes as I could while I'm writing this. It's a very useful tool, which is why we're using TypeScript, because once our code base becomes extremely big, it's very easy to make mistakes. So if we chuck that in there, just to make the point, and then refresh, we'll see DOM loaded. So that means that that has been firing. And just to make it clear that it's asynchronous, if we put a console log here and go DOM not yet loaded, this, even though it's in a line further down, should appear before it. So you can see DOM not yet loaded. So the code was running down here. It attached this event listener and waited for an event, but then immediately started working through the rest of the code. So that's why this ran before this did. Right. So now we've got it loading, but what I want to do is I want to have some sort of place to put our views. So I'm going to make sort of a shell here, and we're going to be calling this, so let's call this main view. So this is a DOM element called main with the ID of view, and you'll see it just here. Okay, it's empty, great, that's what we want. So that view is essentially going to be something that corresponds with the page that we're on. And to start off with, we're just going to load something straight into it. So we're going to define a constant called the view DOM element. So we'll add another sort of, what's to say? So we're going to come up to a new thing, which is a way to select elements in the document. And because I gave it an idea, it's actually quite easy for me to get to, because I can go document.getElementById. And if you recall, the name of it was view. So now that I've done that, I should have access to that view element. You can see that there. So that's the actual DOM element. When I console log on it, it actually gives me a fair bit of information. Not that I'm going to do anything with it just yet. Okay. Now, if we wanted to do something as simple as, say, loading a page, it all eventually boils down to putting HTML in that DOM element. So let's do just that. So view element, any DOM element has a thing called inner HTML, which is a simple text property, which actually allows us to put in pretty much whatever we like. So we could go h2, this is the home page. So I'm making a string here, and that string, so we've got these backticks, which is a feature of TypeScript and also modern JavaScript, which allows us to essentially have new lines. We couldn't do this with a standard string like this. You can see it complains bitterly. But when I do this, I'm able to make this as long as I want. So we'll make a h2 there. This is the home page, and then we'll also put on a just some. Let me get some lorem ipsum. All right, one paragraph. There we go. Gimme, gimme, gimme. Okie dokie. Okay, whoopsie daisy. Okay, so now if we do that, so we've got view element and we set its inner HTML. And while we're setting it, that implicitly gives the web browser the instructions to open that up. So you can see here, it chucked all of that text inside main ID equals view. The alternative and potentially safer version of it is use text content. Now this is not going to look as we intended it to, and the main reason for that is because text content isn't allowed to put in DOM elements. So you can see here that the H2s came out as text rather than as actual elements, and you can see here with the p tags as well. So there is a vulnerability in using inner HTML because you could put pretty much anything on there, including script tags that could run bad code for people. So we will have to eventually deal with stuff like that, but we're not worrying about that right now. So with that, we had ourselves an inner HTML. Now let's say we wanted to have a link in this. And we wanted it to go to a page. Let's say we go to an about page. Let's just do that, right? Seems simple, right? So I've got that link, I'll click it, it'll cause a reload, and then but we're still on the same page, okay? Our application has no idea what to do with this information. So now let's think about how we could do something really simple and straightforward to manage the fact that we have a certain route here called about, and we want to choose which page with that route. So just to start off with, let's have a look at how we can actually get that information. So if you have a look down in the bottom right, what I might do is I'll dock it to the bottom so we've got a bit more width. So if you look at window, there's a whole lot of things, but there's a location object. And that location object has a whole bunch of information about where it is that we are in the application. And you can see, if we look down here, we can see path name. And path name's great because it gives us essentially what we need to know where we are on the web app. And like, you know, the little details are there too. So we can see things like, okay, that trailing slash will be noticed. So it's exactly what follows our server location. So we can probably use that. We can do a really simple if statement, and obviously this is naive. This wouldn't be how you'd ship a finalized code, but this demonstrates the point. So what we're going to do is instead of just using, always doing this, we're going to figure out which page is the right one and then go from there. So let's go, let's do a switch on it. Let's do a really simple switch on it. So we'll get the const current location, and that equals window dot location dot path name, because we will throw away the rest and we'll just assume that we're always going to be served at the root level. So we can assume that that's good, but we'll do something better with that down the track. So what we can do with that is we could just run a simple switch off it. So a switch allows us to say, all right, with this particular switch, with this particular variable, current location, if it equals one thing, do this. If it equals another thing, do another thing. So if it equals this, we will do that page. So if it equals that slash there. And we need to break after that. And let's just say if it equals about, or if it equals about, we're allowed to stack our terms like this. So that way we can get the same thing happening with two different terms. So now we've got an about page. Okay, so you can see here we're on the about page. I actually want to change that link, sorry. So if you jump over here and we run it, you'll see, okay, we've got the home page here, and when we click it, it changes in the about page, and it changes with the home page. Now, there's a little bit of a bit of sleight of hand going on here though, because we're not actually doing this like a web app would properly do it. And the reason why is because every single time, if we persist logs, every single time we click this, we're completely reloading the app. We're getting the HTML again, we're getting the CSS again, we're getting the JavaScript again. Now technically it's cached, so maybe it doesn't matter, but we're also throwing away all of this in-memory storage that we could have. So every single one of that in-memory, all of that in-memory storage will be lost. So this would obviously not be a good state of affairs once we had a complicated app. So what we want now is we want to be able to change between these things without running into, without needing to reload the entire page. And the only thing that will happen is this instruction of view in a HTML, like the view elements in a HTML changing. So with the 13 minutes we have left, we're going to try and knock that down. And in order to do that, we're going to have to deal with a HTML5 API called history. So if we go mdn history. So the web API of history has the ability to go back, go forward, and like some basic page actions, and you would have seen plenty of this in the old days. But the modern days have a concept of push state and replace state. And what that allows us to do, and you would have seen this if you're in any of the day zero streams, is you're able to change what this says without causing a reload. So if we were to go say document dot, window dot history dot app push date, and it has a bunch of things that we really honestly ain't going to use, but then the final argument is the path name. So if we do that there, you can see we moved off to a new location. Or if I was to do that again and kick it off to about, we've got exactly that. So push date is our means to do that, but that doesn't actually do anything else. All it does is set the push date. It doesn't actually set any of the other stuff in motion. But that said though, if we were to look at window location, you will see that it updates as this changes. So if I was to do a push date back to the root, and then run window location again, you will see that the path name has now been updated to that single leading slash. So we should if we run a push state, we should then be able to run this function that's detecting things again and be able to, I don't know, re-render this page. So let's have a think about how we're going to do that. So what I'm going to do, and again, this will not be the final structure of the code. Do not worry if you're freaking out and you're experienced and whatnot, because this will not be the final structure of the code, but merely to demonstrate the purpose of things. So with this function, if we call it update view, and we'll essentially do exactly what we did here. Actually, we'll take the lot. Let's take the lot. So go to 53. Oh, 53. That's not right. 53. Gimme. All right. No, we want all of it, don't we? Okay. Sorry, I'm just having a bit of trouble typing what it is I intended to type. There we go. Okay. So with that update view function, all we've done is extract it so that we can call update view. All right, for those who aren't familiar with JavaScript, the whole concept of a function is we're just making something that we can call repeatedly from a bunch of different places and get something to happen, whatever it is. And that something we want is to update the view. So you'll see that our code currently works. This is the home page, that's great. When I click about, this is the about page, that's great, but we've still got that reload in there. So we've got to do two things. The first thing is we've got to catch any click that happens to a link. So when you talk about apps, actually, let me just talk about this really briefly. So when you build an app, there can be a temptation to add event handlers everywhere. Like when you click on this, it'll set things in motion and things will happen. But I prefer to try to keep as close to possible as how documents actually work. And one of the great things about this is all the links technically still work. They're all working in good order. And what we're going to be taking advantage of is a thing called bubbling, which means that when you click on this event, you don't have to put an event listener on that A tag to actually find out what's happening. What you can do instead is we could do something like document element. So to be really clear what the document element is, document element is the body tag. Oh no, the HTML tag. My bad. That's amateurish of me. Maybe I'll actually bind it to document.body. Let's do that. Yeah. So we'll bind it to document.body, which is that body element that should surround pretty much everything that forms our web app. So what we're going to do is add an event listener for clicks. Alright, so we're going to console log out the event, click, and what we're also going to do is prevent default. So prevent default is a thing that you can call on nearly every event. What that essentially says is whatever you would normally do when this click happens, I don't want you to do it. And that way the JavaScript can tell it to do something else entirely, which is how pretty much all web apps are built. Eventually they will have prevent defaults and they will force something to happen that the browser wouldn't normally do. So having done that, if I click here, nothing happens. And if we go to the console, you'll see this click event. And you've got some important information in here. You've got the concept of current target, which will have been lost now. Let me see if I can actually get that. Event.current target. Right, so if I click on here, okay, yeah, here we go. So when you click on this event, click on this thing here, what happens is that event, before it really does anything, it will travel all the way up to the up the DOM, and it's waiting for JavaScript to handle it, and it will handle the JavaScript wherever things ask it to. And if ever event prevent default gets called, it will stop doing what it was planning on doing after it's done that bubble. So what I mean by bubbling is it will check if there's any event listeners on this A tag, and if there's no event listeners on this A tag, it will then check on the main. And if there's no event listeners on that, it will then check on the body and then on the HTML, and then that's it. Then it will just go ahead and do whatever it was planning on doing. There are ways to short circuit this process. So there's an event thing called stop propagation. And that stop propagation is going to be really important for the times when we want to stop things getting down to this click handler. Because we can just say, at a higher level, we can handle the event and say, nope, stop propagation. And then when you've, what's the way to say this? So yeah, stop propagation and then do what I tell you to do and don't go down to the body. But for the moment, we won't get too much into those details there. So what we're going to do here is we're going to take that target, we're going to take that event and figure out what the target is. So if I click on it, you'll see that the current target, that's what this body was. The current target is where the event has reached, but the target is where the click originally was. Also, original target is available there. But that target is really important information because it means we can handle pretty much any A tag in the app and do something specific with that information. And what is that something specific? Well, let's get into it. So if we have a target and it has a tag type, oh geez, this has got heaps on it. Yeah, if it's got a tag name of A, then we know it's an anchor tag. So if event.target.tag_name, or rather we need to check if it actually has an event target. I mean, just in case. So if the tag name equals A, then we know, all right. So here's a problem. It doesn't exist on event target, and that's just because of TypeScript things. We actually want to tell it that we want to treat this as a HTML element. So we'll just go ahead and do that, and that way it knows that it has to have a .tag name. Anyway, now that we've done that, if we know that it's an A tag, then we can get to this stage where we check something else. And that's something else, so we'll just go get the anchor, and that'll be the event.target. And we're going to do something with that anchor. And again, I'm just taking it slow so we can demonstrate the point. I don't mind if I run a little bit over just to demonstrate how this works. So when we click on it, you can see we've got the ahref there. And, the anchor tag. And inside it, it's got a property of href. And we can get that quite easily. We can just get href, and that'll give us a location. So console log href. Anchor.href. Alright, that's right. Let's make that a HTML element. And that'll quit barking. Oh, we need an A element maybe. HTML anchor element? HTML anchor. I don't know what the right type is for it. Oh, that'll do. There we go. Okay, HTML anchor element. Good. So you can see here we've got that path. Very good. Now we need to figure out what it is exactly that we're going to do with that path. So let me think the best way to do this. So if it is location.hostname. Yeah, there we go. We got host. All right, so we need to figure out whether this is a link locally or a link going beyond us, because if it's a link going beyond us, we don't actually want to make use of it. So we're going to take our root, which is going to be window.location.protocol plus these two slashes plus window.location.hostname. Oh no, we can just use origin. There we go. We've got origin. That's fine. So if we go window.location.origin, we'll have everything we need for the root. And the reason why this is important, because we want to go that if anchor.href and anchor.href.indexOf, if we find out whether that root is inside the anchor and is at the start of that anchor, then we know that it's going to lead somewhere that we want to go, like somewhere within our web app. So let's just check. href is inside the app. And the reason we would do a check like this is so we wouldn't accidentally run push state on something that says something like that goes to Google or something like that, right? Because that goes off the site. We want it to behave like normal when we click that one, right? So the href is inside the app, it's determined. Okay, let's go back to the home just so we can demonstrate that point. So if I click on Google, you'll notice that it didn't decide that the href is inside the app. So we only want to prevent default if it's inside the app, okay? And what we do from there is we're actually only a hop, skip, and jump away from getting this done. So what we want to do from there is we want to go window.history.pushState, and then we just put some throwaway code in the first items because we don't actually need those first arguments too much. But the last one is very important. It needs to be essentially the href. I'm actually not sure whether it's the href or whether I need to strip away the tag, but let's just try that one and see whether that works. So we clicked it, and if you look up the top, you'll see that our location changed, which is what we wanted, but nothing changed in the page. So what's missing? Well, we're not calling update view, so we're not actually checking the path name and checking whether we need a new page. So how about we do that? If we call update view at this point, that should result in these links behaving as we expect them to. Click about. You can see we changed to about, click about, home. And just to make it really clear that there are no extra events taking place, so let's trash the logs. We'll now persist the logs. So we'll do a refresh. If I click about, you'll see that no new page reload is taking place. So every time it's just swapping between them. And the moment I click go to Google, it goes to Google and just behaves like it had before. And it should also respond correctly when I reload the page. So there you have it. We have some really basic routing. Obviously, it's super crude at the moment, but we're getting right into the basics of how these APIs work. And then we will build this up so that it can actually be a robust routing solution for our later use. All right, so that leaves us at the hour mark. So we're pretty much going to finish up there. So I'll chuck this commit in. That'll go up to the ether. So day one, and implement basic routing concept. And I'll push that up. So it probably bears mentioning after I've done that little bit of code that the way I approach code, funnily enough, is a lot like how Handmade Hero approaches his code. So if you've heard him talk about semantic compression and all that, then there's going to be, I don't call it by that name, but certainly there's a lot of this idea of moving towards where you want to go by first exploring. So you open up a range of possibilities about how your code's going to look, and eventually you compress down into a final solution that properly addresses your concerns, and you've actually explored it with lots of usage code first. And what I find is that ends up with better results for me than it does trying to overthink the architecture or all that sort of stuff. Now, obviously, there is a benefit here. I've done this before, so clearly I have a rough idea of where I'm going. But it's really important to explore and then compress to be able to know that you've actually done the right things for the code base that you're working with. So we're going to be taking the time to do that properly as we work through this, because first, it allows me to explain the code a lot more, and second, it means that we will hopefully end up with a structure that is well considered and not pre-architected in some sort of way that just assumes everything's going to work out. Because unfortunately, unlike making a house or something where you build a blueprint and then assume that blueprint will hold steady the whole time, this is more like making the blueprint than it is like building the house, if that makes sense. So you're constantly making decisions as you work through your code, and it makes no sense to just tie yourself down just because you thought it would work out in the strategy phase. So it's important that we're always making decisions about how we structure all this code. At any rate, that pretty much finishes up for the stream for tonight. I pretty much open the gate to any questions. I know there's not a lot of viewers because I haven't been doing much work in terms of publicizing this and whatnot. But I do very much welcome any questions. When we go through this, if you watch these videos on YouTube and come up with any questions, I'd welcome you to either @ me on Twitter. So that's @ Maluco Marinero. I know it's hard to spell, so I'll put it in the description real soon. But there I am. I'm that guy. So you can @ me with questions there. You can also add issues to the Weekends Web App repository. So you can do that just by going onto GitHub there, clicking on new issue. It won't let me do that because I'm not logged in on this particular browser, but you can click new issue there and add a question, and I'm more than happy to answer it. If you're live on the stream, you're more than welcome to ask your questions on the chat as well, as I'll always be watching, although sometimes I think the chat crashes, so I will make sure to refresh it as it goes, just in case I miss them. But at any rate, I do very much welcome questions. I want to make sure that this is as accessible as possible for beginners, and also just allows for everyone to see a process from start to finish, so we can really uncover all the nitty-gritty aspects of building something from scratch. We will not be we will not be a completely no library scenario. There are certain things that it's just nice to have libraries for, otherwise I'll be stuck in minutia all day. So we will probably be using React, Redux as a library, but then there are a lot of things that won't be implemented for us, and I don't tend to use all of the ecosystems that surround these base tools either, mainly because I find I'd rather work with the web APIs directly in a lot of those cases, and I find sometimes they're quite obfuscate. They obfuscate what you're trying to achieve by trying to put too much into one technology. And if there's one thing I'm big about, even though I've been working on React for a very long time, as long as it's been open sourced essentially, I never want to handcuff myself to any particular framework, because I want the skills that I have, and hopefully the skills that you gain from watching this stream, to be largely timeless, because the web APIs persist for a very long time, and it never goes out of style to be good at HTML, JavaScript, and CSS. It doesn't matter all the layers on top. It never goes out of style to be good at all the base layers, because it means that you can work in pretty much any scenario. Well, that is pretty much it. I have no questions to answer at this point. Our next stream will unfortunately not be tomorrow, mainly because I've got to take the kids. I have real life commitments. But we will be having a stream on Thursday night to make up for it, and that stream will start off at 8:45, so a little bit later, but we will be back to normal schedule after that. So if you're watching this on YouTube, thanks for watching. If you're watching this live, there's only one of you, but thanks for watching, and I'll see you next time.